cost overruns, and a lot of other things. But today I thought, we'll just focus on the technical aspects as to what can go wrong in the project and what are different parts of the world, trying to implement different processes within the construction field such that the risk can be mitigated, or it's humanly impossible to have zero risk on any project or anything that we go in, right? So today, what I'm going to be speaking about, or what I'm going to be sharing, will just be based on the experience that we ourselves have seen from owners, going bankrupt, to how a project which started with a loss but gained itself to become a normal or a break-even or a profitable project, versus what is the right way that huge projects have already started implementing such that the risks are mitigated. The major issue in any construction project, whether a problem in a project, is faced towards the end of a project or whether it's in the mid, it is how you shape the project at the start. Like the saying goes, a good start is half job done. And that's true into your daily lives, into any kind of industry. And for the starting part of a project, it's the design, right? When I say design, it does not mean a well-done design. It's the design phase, the entire design phase, which was not there initially. Probably say, if you consider 50 years back, it was just like an owner coming in, he would hire an engineer, an architect, they would finish off the design without knowing it can be built or not. That design will be floated out as a bid to, say, general contractors and the subcontractors. They would give a lump sum money. That type of. So there are major four project delivery methods. First is plan and spec, where it is all lump sum based on the design that the designers and the architects and the structures have done. They would give a lump sum estimate. The lowest estimate will be selected, and the project will be floated out to that company, and then start working on it. The second is design build. That was an evolution as to how can we mitigate the risk, because on the first part there is no collaboration between the designers and the contractors. The designers don't know how to build, and the contractors don't know what goes into the design aspect of it. Right? So to mitigate that, came in the design build delivery method of construction, where the owners hire the general contractor. General contractor basically is responsible to design, within the realm. So they would hire an engineer, like an MEP engineer, an architect, a structural engineer, and a collaborative effort will be done where the general contractor will be overlooking what's happening, whether this can be built or not, whether the equipments are available that needs to be ordered to produce everything in timely manner or not. So design build is a very popular method on, I would say, a small to medium sized project as of now. Then came in IPD, which is called as Integrated Project Delivery Method. These are famous for bigger size jobs like airports or metro rails, which is going on right now, where the size of the project is so huge that it is almost impossible for designer being situated in Delhi, architect in Bangalore, and the project going on in Pune. It is impossible for them to collaborate everything, even though they are working under the same contract of the general contractor. So came the integrated project delivery method, where there will be a site office, representatives or a team of each and every contractor, MEP designer, architect, structure. Everyone will sit there in the same site office, and throughout the project life cycle, they should not be facing a problem where something went wrong onto a job site and a question was raised, and they have to send an RFI to somebody sitting in some part of country or maybe different world. A lot of metro rails are designed by foreign designers, right? Not everything is happening in India. So those method in that method, everyone is in the office. You get question and answers to the questions done immediately, and that helps into cost overruns and schedule overruns. And now the fourth one, which is the most famous one, I would say it's still in the testing phase. Bigger jobs. Right now we are working on a metro project in San Francisco, where they are implementing this, and that project is called as progressive design build. The best part about this, how it helps into risk mitigation is there are the design build contractor, basically the general contractor, or PMC or CMC, whatever we call it in different parts of the world, would get two different contracts. The first one will be just for the design part of it. So say, I'm Turner Construction, we were just discussing about Turner. So if Turner is given a contract to build, say, so-and-so metro, with 5 tunnels in there, with 10 stations in there, a $20 billion job, while they are the selected contractor, they are not selected based on their pricing. So the owners, what they do is that they will be in progressive design. The owner's responsibility and the know-how increases very much, because they'll have to first prepare their estimate themselves. They will not be depending on a contractor to give them, okay, I will do this project in 18 million, I'll do that in 20 million. They would exactly know what it's going to cost. So they're spending some amount initially itself to hire an estimator for them. Now they float out a bid saying that, okay, we have a project where we have estimated approximately $20 million to do this, and we have a timeline of 4.5 years to finish it. Who all can do it? So 5 people raise their hand. Now they will ask them to give their approach. It won't be pricing. It won't be that, okay, how much price I take. It will be how will you do it? What are the methods you do it, and what's your experience based on it? So based on that, one design build contractor will be shortlisted. Now that contractor will only get the design contract only, with the criteria as to they have to achieve within this many days, within this many costs. If you are able to come up with a design in 1.5 years, only then you will get the second part of the contract, which is the construction contract. So what happens in this process is the entire design phase, which is say if we are starting from schematic design, then comes the design documentation, then comes the construction documentation, right? These are 3 major phases of design. In that, each and every, so it's not like the design build contractor will submit a design at the end of one phase. That, okay, now this is my submission for schematic, this is my submission for design work. That doesn't work that way. It will be like every, say, 20% SD phase is finished, you will have to submit deliverables, and their deliverables include 3D, which is space constraints and space coordination, 4D, which is how will you fit in for the 20% design that's done so far. What's your plan to achieve the schedule that was given? So time constraints being taken care of, and then comes 5D. Okay, now 20% work is done. You are going to be finishing it in next 3 years. What will be your costing? Is it coming still under the budget that we have proposed or not? So every 20% of schematic, then 40, then 80, and then 100, or it could be 25, 50, 75, 90, and then 100. There will always be that last 10% remaining, on any, and that happens on schematic design, design documentation, and construction documentation. So in this process, what happens is that the owner has much more control over what's happening. It's not like people are working in silos. Nobody knows what is being done, what cannot be done. Also, while this is being designed, every 20-30% when something is upgraded, right now my electrical is being designed at 20% level. That means I have my control panel already sized. How many feeders will be required, what all major components will be there. So at the same time, if they are running the cost and the schedule, the design build engineers will have to check with the equipment suppliers as to, hey, are these things available within time to be given or not? Because right now in the world, the issue of supply chain management has gone down so ridiculously bad that the projects are being delayed just because of that. They have placed an order a year back, and you do not get the construction material in time. So all these things are being checked right at the start, and that is done at each progressive submission. There could be 20 submissions before the design is finalized, and at each stage, through the visualization of 3D, 4D, and 5D, the spaces are cleared, the schedules are cleared, and the cost is cleared. So now imagine, by the time that 100% is there, the owners are in such a good situation that they exactly know that will this design build contractor, whom we have selected, will they be able to deliver it or not, right? And would that be within the budget or not? It's not like plan and spec, where it's just a fluke. That somebody gave me 10 lakhs and the other person gave me 15 lakh and select the 10 lakh contractor. In that case, there's no way for the owner to know whether they have the capability or not, and whether they will be able to do it or not. And it's much easier, we have seen in a lot of projects, not just in India, but in various parts of the world, that the lowest bid contractor is selected. Now they start playing the rough game, putting in the change orders. There will be change like, hey, there's a design change, I need more money. And then the owner, the project has already started. The project has already started, and there is no way for the owner to say no to it. You will have to give the additional amount, the additional change order which is placed in, and the owner's hand are tied. You will have to go with it. Versus in this case, there's only one contract, there's no money lost, the project hasn't started, and at the same time, everything is vetted through equipment, schedules, costs, like I mentioned, and they are in a better situation. So, this is just an explanation to, if the initial phase is done right, the owner is in much better situation. So there are a few projects that we have done in this way. First I'll explain about a project where the owners messed up. Even while implementing the desirable contract, like I mentioned, it can still go wrong. And versus there are projects where things are done in the correct way, and how much have they saved over the time. So this project called as San Francisco Conservatory of Music, we got onto this in 2017. Initially, we were invited to be the bidders for the MEP, Mechanical, Electrical and Plumbing Engineering. We came in second on our pricing. The owner selected the lowest one for design. It was not the owner actually, it was the general contractor, because they were the design bill contractors. They were responsible to hire the engineers under them. They were responsible to hire the architects under them. So the lowest bid engineer came in, low price, but never came with good quality. The engineers actually knew how to design it really nicely. They did their job. They made sure that the permits are in place, everything gets approved, and BIM was a part of mandate during the design phase as well. It's not just during the construction phase that BIM is important, but design phase BIM is much more important than construction phase, because if a lot of this coordination is done at the start, like I said, if 80% of the issues are cleared before even we start digging the ground, things will be much easier. And they did it. They hired a third-party BIM who developed the entire model, but the drawings were still done in the CAD. So the model, the 3D model, the 4D model, which they were claiming that they are using, was never actually put into a piece of paper. And what gets approved and what gets built is a piece of paper. Those are shop drawings, right? Until and unless those things are translated, the errors that you find in a model, if that is not shown into a shop drawing, you would never know what you are building. So they made that mistake. The shop drawings were what was approved by the town planning, by the city, and then came in the contractors. They started building. They had a budget of around $2 million to come up with the change orders. There's always a budget, and that's what is construction administration cost. During the project, there will be changes. Even though you design it in the best way possible, it is almost impossible to come up with a situation where there is no change. There will be some change. The CA budget was exhausted within 3 months of the project start. The BIM coordination, had around a cycle of around 6 to 8 months onto the schedule, and it was a 12-story building, in the downtown of San Francisco. The coordination of just first 3 levels, which was a dormitory, if it's dormitory, what that means is that the walls are all stacked up. The room here, and there will be a room above as well. So whatever coordination you do on floor 1, the same can be copied up on 2, 3, 4. But if it's other kinds of things, so after floor 5, there were music libraries, there were performance halls, there were auditoriums. All these require much more utility than what a classroom or what a bedroom requires. A bedroom will be 1 fan, 2 lights, one maybe a duct for HVAC, and once you coordinate that for one floor, you just copy and paste. But the design was done in a bad way, I should say, that nothing was taken into consideration in terms of space. So hey, the coverage of AC light was nice, but can I actually fit in there? Has the architect given me enough room for me to run something in wall or over the ceiling? And nothing of those sort of items were considered, and they went into a problem. When they started building, things were not happening. Then the general contractor basically brought us in, and they mentioned that okay, now while we did not scan the drawings, we cannot edit it legally. We started from level 6 to roof because that were the difficult aspect of it. The construction was stopped for around 5 months because they could have afforded that rather than wrong things being happening on the side, because that's much more difficult to fix. In the virtual world, the fixing is easier. So we went in, we took their drawings, we modeled it correctly, we worked with the general contractor, the architects, the structure, worked out the spaces as to how to fit in and what kind of equipments are already available to be built on the site, because the lead time, the time was wasted. They could not have okay, place an order, something will come 8 months down the line. Those lead time is no more there. So we had to work with the vendors, the suppliers, the engineers, the architect, and the contractors to make sure that whatever we come up with, that's something that they can build the next day. And what took them 6 months for just doing 3 floors, they were able to finish the coordination process in 1 month after we finished our work. And now imagine the same thing what we did. It was the engineer's job to do it, but they did not do it right. So design phase, coordination, design phase build, which is what I explained. When there is a progressive design build going on, that progressive design build is a way that owner forces everyone to give at very short intervals that they are able to review it as well. Versus towards the end of design, you send me something. I don't know what has gone through those 8 months of design phase or 2 years of design phase, and then when general contractor starts building it, that is only when you realize, okay, this is wrong, and that's a wrong time to realize that this is wrong. So progressive design build is where the world is moving, and I mentioned about a project that is implemented it in the right way. So this project is called as Silicon Valley Metro Rail. It's around, I would say, $32 billion job, a super big job, with multiple tunnels. There are the general contractor, there was no contractor within just US who could have taken this project alone. So there's a Japanese contractor involved as well, and then there's a Ukrainian engineer, who is doing the engineering for it. And the way that owner wrote up the contract was such that at every 20%, of the design phase, I used that as an example when I was explaining. Every 20% we had to submit in. We were the lead build on that project, where if whatever comes from the progressive design build contractor, we had to assess everything. We had to see that everything is done in the right way or not. And the project, which I mentioned, which, if I'm not wrong, which was at around 28 to 30 billion, or was supposed to be there by owner's estimation. Towards the end of the project was finished at $26 billion. So around saving of $6 to $8 billion on a project by just spending, say our fee on that would not even be 0.5% of your total project. They did it in the right way, mitigated risk at the start, understood what is going to be a problem few years later. Just that 0.1 to 0.2% of extra money spent, they are able to save almost $6 to $8 billion on one project. So, risk mitigation on a construction project, when it comes to technical aspect, it is all about how you shape up a project from the start and make sure that the whatever is to come, we don't just rely on something which is on air, which is on cloud. And make sure that the owners have to make sure that how to write up a contract. We actually have a paper published within Autodesk, about this. We worked with a contractor, to write up this, that what should be the language of a contract when you are hiring a general contractor an owner or owner to engineers, owner to architect, and what are the responsibilities. The responsibility matrix is very important to be discussed and defined at the start. So yeah, this is a little bit that I wanted to share with you guys. I don't know how much of it has already been touched as a part of curriculum. I guess it hasn't. But this is something. Lot of times it's not even taught into academics, risk management, or even if it is, it's very superficial level. But the moment you start going into the field, you start realizing that what are the aspects that you need to learn, how things are happening, and what are the owners doing to make sure that this is being implemented. So, open to you guys. Any questions?
So like you said that we know before the project starts that what's going to happen. So can you just give us an example of how is it different from the traditional?
Again, repeating the words progressive design build. That's the technical term that goes into it, where by the design has been developed at very short interval. You have been asked to submit 3D, 4D, and 5D models. And when you are doing that, at every 20%, whenever a design is progressed, you have to make sure that the progressed design is in compliance with the schedule and is also in compliance with the cost. When I say within schedule, there are a lot of things that have to fit in as to, hey, to build this, I will require so and so labor. I will require so and so suppliers to fit in all the, provide the equipments and all the materials within time. And when it comes to cost, it's the engineers, the architects who spec out all these things. I'm using, say, a Panasonic TV to place here, or say a Siemens panel, a control panel, or a fire alarm, or there's, all this, whatever I'm specing out, because when I say spec out, that means that the engineers are the one who write up what are the things that are going to be used on a construction site. And that goes on to the owner's representative, who finally signs off as to, hey, yes, you are okay, designing this. And once that is designed, that goes on to the town planning, and they are the ones who approve it. Now, if all this process have already gone through, and then the general contractor realizes that either the model of the DD or the model of the panel that was spec'd out is no more, being built. It's discontinued, or it has a lead time of 2 years to be delivered on a job site. That's going to cause a delay, right? So then, in that case, the RFI will be raised as to, hey, now we have to replace this thing with something else. The engineer will again start working on it. Will have to replace with some other, material, equipment, whatever. Have to again go to the same cycle of owner's representative, town planning, approval, and then it comes back, and then it gets ordered, and then again there's a lead time of say 5 days, 10 days, whatever. So if all these things were done in advance, these things would not happen while the construction is going on, because time and money spent during construction is much more expensive than if it is being taken care of during the design phase.
Is this method suitable for small scale projects?
So for small scale project, progressive design build isn't, but just design build construction is suitable. Lot of projects within India, if it's so. The way that Indian industry is working is residential is very differently tackled to other kinds of commercial or institutional or hospital buildings. So in residential, more or less here, it's just the developer, who develops it, right? Versus in other part of the world, if I want to build something, I will still have to go through the process of hiring a contractor who eventually just would be a union labor contractor. Who will be doing it. I'll be managing my own site, but the process still remains the same. There will be an engineer. Nowadays, I'm hearing that a lot of even the residential projects are requiring a PMC, a team, engineering team, architecture team, and all of this can be under the roof of the owners. While do check what's happening, they need to have a contractor who handles them, so that people are not working just within their silos in their office. They need to coordinate with them. So While progressive design build is just for higher scale projects as of now because it's still in the tasting phase, but design build is being implemented across the world, even in India, and that's a more suitable method than lowest build approach. Just money is not going to help you come up with something. And the reason why people are preferring Planet Stack or lump sum or the lowest bid is because owners feel that okay, I want to reduce down the volatility of a project. I want to restrict everyone to say X amount of money. But that is not how it works on a job site. If you are more realistic and more open to changes, but have those changes done at the start rather than during or towards the end, then you will be much more in a better situation than just being rigid with a planning spec. Right?
Hello, sir. I'm Pradnya. I'm working as a junior research fellow here. So, sir, and also I have joined TechnoStruct for learning the BIM because it will be helpful for my project or research. So, I wanted to know with the help of or in a traditional method, we face a rework. Means if suppose design is not as per the space as per the specification, contractor doesn't build on the site, we have to face the rework. So what happens with the help of BIM or how it tackles or overcome the problem of rework?
Sure. So if BIM is done in the right way at the start, like I said, design. Initially, what people thought is that building information modeling or virtual design construction is not for design phase. It's just meant to be during construction, where once the design is finalized, you model it virtually, you coordinate it, and then basically then build it from there. That is still better than doing nothing, but implementing the entire virtual design construction space within the design phase removes pretty much around 70 to 80% of rework because so you have to understand one thing, that designers, architects, they are not contractors. They like to, architects are best at sketching out whatever they want, but that does not mean that okay, this curve is buildable on a job site, right? They would like to make it pretty but not necessarily functional. Versus a contractor, they like easy stuff, straight, wall onto wall, but the combination of both is very difficult to achieve, and this design build is what comes in. So now, if the contractor is already on board when the design is being built, the contractor will be able to pass on the information to the designer while he or she is designing it as to hey, you're doing it, nice, it looks great, but for so and so reason, we will not be able to build it. So tapping that hand at the right time reduces down the rework towards the end, because if the design is done, the permits are in place, and somebody is already ready to be hired to be built, then the entire process goes in. So that is where design build just comes in. Design build is just a subjective name. It's a process. It's while US follows the name of design build, here it could be whatever XYZ. The collaboration of contractors, designers, architects, is what a design build process is. And if that's taken care of in the design phase, then that's the best way to mitigate this.
I would like to add here that, of course, rework happens only when there are defects in the work.
Mm-hmm.
So it's majority related with the workmanship.
Yeah.
So somewhere it's not just limited to the stakeholders, which are high-level stakeholders who are actually responsible for the delivery of the project, but also the lowest level executors, like
Sure.
the laborers. Because if there is a lack of communication, and as you said that if there is a difference between what is actually there virtually and what is there on the shop drawing, in that case, such issues are going to happen. I mean, there will be cases where entire slab is demolished because of just using wrong mix,
Yeah.
right? So that sort of rework, how do we actually take care of such sort of rework where there is workmanship or there is what you can say the prerequisite quality of the requisite quality of work is not attained.
Sure.
In that case, how is BIM really useful? We see that there are clad detection. Clad detection is it can be done prior to actual construction phase. But but again, during construction, if such issues occur, in that case, how BIM will intervene?
Great. So I'll again answer this by a few few examples that we worked on ourselves. So in the example you gave, if the grade of the concrete was used wrong, BIM can do nothing because concrete is not something part of it. But if the thickness, say the slab thickness goes wrong, the surveying components are going to be bad, right? If the slope is not given right, then that can also be attained through BIM. If the stirrup sizes or the gaps between the stirrup or the entire concrete or the steel building, if that is gone wrong, then that can be corrected through the BIM process. So by example, say we just discussed, I just mentioned about structural, say stirrups and the rebars. So what we do is that once and say there's a lead time of 2 days, after the rebars and the stirrups are all tied up and the formwork comes in for the concrete pour, we have 2 days of lead time. That's what we have added nowadays. And within those 2 days, we have laser scanning that goes out. Point clouds is created of what is being built, and then we have created an application through machine learning ourselves that whatever is being scanned is automatically converted into a model, and then what was proposed versus what is built is being compared. And then whatever we have a tolerance of, say whatever percent that the owners, the contractors have agreed, this tolerance is okay. If not, then and that's where our India team comes in. The scanning is done say at 6 p.m. US time. Then it's around 7:30 here in the morning. Our team comes in, runs all these processes, comes up with the errors wherever it has happened. They redline it. By the time we wake up there, the red lines are prepared. After the tolerance, whatever is wrong, those things are mentioned in the shop drawing, and then that is being dispatched to the steel erector, whoever was there, and that's corrected. So before even the formwork is done, all those things are done. There's this project called as Google Bayview. That's the headquarters of Google that's being built. By the end of this year, they're going to start. That's in Mountain View. Now, the architects, how they've done is that it's a 2-story building, a huge project. But the second floor has very complex roof type, and that roof membrane is not strong enough to hold the utilities on it. Ideally, in the US, everything is overhead. Because it's not concrete structure, there's less of concrete being used, just for columns and slabs. There is always a lot of overhead utilities going on. So, because of this complex roof system, all what was supposed to go on the overhead of roof 2 is now on the overhead of the floor 1. So there's overheads of floor 1 going there, and then there is overheads of floor 2 also going there. So the complexity and the amount of utility in there is ridiculous. I mean, it has taken us 3.5 years to coordinate that, and it's still in process. But basically, the tolerance have gone down to such a level that it's almost humanly impossible to be right always, because that project is huge. I mean, we've been there, the construction has been happening since 6 years and 3.5 years of coordination. So, what we've been doing is, we call it as blue bangers, right? Say, like this. You see this thing, the clamp that is holding the fire sprinklers here. That there's a technology, where once this is surveyed, once this is modeled, coordinated, this is called as trimble points. So it's basically a surveying technology. We put a trimble point, which is ideally in a computer, it's just a point, but it has X, Y, and Z coordinates in it. And then there's a robo called as Nomad. So basically, it's just a tablet. But that tablet is able to read X, Y, Z based on the 0, coordinates of the site. So a guy, basically will go, and wherever he sees that, okay, I have a point here, he will go there, he will color it, right? So all this are marked up all over. Wherever there is a floor penetrate, you need to have a 1x1 box, or say a circumference of say 5 by or 5 feet long, for not 5 feet, but whatever floor penetrates are there, you have to put it for HVAC or conduits or whatever. You mark it up using this trimble technique. You put in there, then the blue bangers are inserted in there. It's basically just a rotational thing, and once that is done, again, our laser scanning team goes out, scans the point cloud, and comes back, because right now even if one of this hanger is off by say 1 inch or 2 inch, that is going to clash with something which is already there running, which is going to be running 1 inch. Because of the heavy amount of utility in there. So every day, whenever this site is being trimmed and the blue bankers are inserted, we have a scanning team who goes there, sends out the point cloud to our India team. Overnight we review it and we make sure that because if the supports are in place, the pipes, the HVACs, the conduits are going to be in place. So before these things are installed and just after the blue bankers are inserted, we compare that against the model. The deviation there is very small, and the next day they are informed. It is much cheaper to just unscrew and put it 2 inch left or right wherever it is supposed to be if they have messed it up, because humans do mess it up, and the lead time with that is just about 1 to 2 hours of fixing next day, and that corrects it to almost 100% correction. So these things, basically BIM is helpful into QC of all these things, and it automates it. While a human person, a QC guy can go and check all these things, it is going to take him months to compare all the, say we talked about, discussed about the stirrups versus, this. It takes a lot of time, and technology can just do it overnight. So.
Thank you for the elaborate answer. Any other question? We'll take one last question if any. Does anyone have any question? Okay, so since we have a team of TechnoStruct experts over here,